Hi everyone, Mr. Rivetto back, this time for lesson 4 of Unit 9, our Intro to Trigonometry. And last lesson we talked about finding exact values for trig functions in the first quadrant, and that meant all of the angles we were finding exact values for, aside from the quadrant angles we also talked about. The 30-60-90, the 30-60-90 right triangle and the 45-45-90 right triangle allowed us to find exact values for when the angle measure was 30 degrees, 45 degrees, or 60 degrees, right? And those were all in the first quadrant because they were acute angles. Today we're going to be talking about finding exact values of angles that are larger than 90, which means they're going to end up in quadrants 2, 3, and 4, right? Because 0 to 90 is all in the first quadrant, and all angles greater than that are in the other 3 quadrants there. Okay, but in order to do this, we actually need to know the exact values of the trig functions in the first quadrant here. And we're going to make use of what's called a reference angle. So let's just get right into it here. In order to be able to calculate the exact values of angles larger than 90, we're going to need to find what's known as the reference angle here. Okay, and the reference angle is always, let's highlight this, between the terminal side and the x-axis. It'll always be an acute angle that way, but depending on the quadrant, that's going to change the sign of our trig functions. Because remember from the ASTC chart, depending on what quadrant you're in, whether in your quadrant 1, 2, 3, or 4, different trig functions are positive and negative where we are here. And visually what this reference angle is, what this picture is showing us, let's say this line here is our terminal side. What we mean by the reference angle is the terminal side of the x-axis. We mean the angle it makes with the closer side of the x-axis, we should say. So in this case, the reference angle is this little one right here. Let's just mark that. For this terminal side, this is our reference angle, right? And we need to know what that value is. Okay, that's like our other theta there, right? I say other theta, but I mean, if we normally measure our angles like that, oh goodness. If we normally measure our angles from the positive x-axis to the terminal side like that, we need this sort of supplementary angle right there, which is what that terminal side will make with the negative x-axis in that case. And if you notice for any of these, wherever we do them, let's do another in a different color for as an example. Like in the third quadrant, this would be our reference angle here. And in the fourth quadrant, our reference angle, if we have a terminal side there, would be that one, right? And we notice those are all acute angles. They're less than 90, which is good because those are the exact values we know of, right? So our process then, what it's going to boil down to find the exact values of trig functions greater than 90 degrees is we draw an ASTC chart, and that's going to help us figure out whether our trig function should be positive or negative, right? That's going to get the SIGN sign of our trig functions correct. And then we need to find that reference angle, which is what I was just highlighting there, which is the angle with respect to the x-axis. And that's always going to be an acute angle, which we should know the exact values for from lesson 3 before. All right, and then we're going to go ahead and rewrite the problem as the function of the reference angle. And what we mean by that is we just put in the correct SIGN sign and then the acute angle we find from the reference angle. And we'll use our special right triangles to fill in those values. So let's just do a quick example so we actually know what I'm talking about. It's much easier to learn math by doing it. We all know by this point. So our example, we have the sine of 300 degrees. So first off, I need to know my axes. In this case, I need to know where I am. And this is what we were practicing early on. We need to know where 300 degrees even falls. So 300 degrees, my angle is going to be greater than 90, 270, 180, 270, a little bit further there. Hate when it does that. 300 degrees is somewhere over here because it's greater than 270 degrees, but it's less than 360, right? In this case, our reference angle, let me switch colors for a second. Our reference angle is going to be this one here. So the question is, how do we figure that out? Well, if we're looking at this, if we go all the way around the circle, if we go all the way around, this would be a full 360-degree rotation, but we've only gone 300 degrees. So one way you can figure this out visually is just by looking, well, how much more would I have to go? Of course, that's just 60 degrees left, and that would be our reference angle in this case, right? It's the angle we make with the positive x-axis. So just to return to our steps, though, now that we found the reference angle, I sort of jumped ahead. We have our ASTC chart here. We're looking for the sine of 300 degrees. Well, we need to know, is the sine, S-I-N-E, positive or negative here? since we are in the fourth quadrant with a C there, only the cosine is positive there, which means our function is going to be negative, okay? So I'm putting a negative sign there. Sine of 300 degrees is equivalent to negative sine of that reference angle of 60 degrees, right? So we found whether it should be positive or negative with the ASTC chart with step 1. We found our reference angle just by sort of using that picture there. And now our function is equivalent to this. And then if we think back to our special right triangles here, our 30, 60, 90 right triangle, remember they are in this ratio here. So our 60 degrees, this is the opposite, that's the hypotenuse. Sine of 60 tells us that this is going to be equal to negative sine of, using SOHCAHTOA, radical 3 over 2, right? So our strategy for solving exact values for trig functions in quadrants in quadrants 2, 3, and 4, anything that's not quadrant 1, is to sort of break it down into a problem that we already know how to handle. We find that reference angle, which means it's going to be an angle between 0 and 90, an acute angle, which we do know we can use our special right triangles to figure out here. And we use the ASTC chart and what we figured out last lesson to figure out whether this should be positive or negative. And this is where I was talking about it's very important to know what quadrant you're in and what trig functions are positive or negative there, because it greatly affects your answer. Negative radical 3 over 2 is not positive radical 3 over 2. These are completely different things. Sine of 300 degrees, while it has exactly the same numerical value, magnitude or absolute value, you want to say, of radical 3 over 2, sine of 300 degrees is negative, whereas sine of 60 is a positive thing, right? So we need to know what quadrant we're in. So the best way to do this, we just need to practice a little more. All right, so let's go through a couple of these. We want to find, I'm going to leave number 1 for us, but let's do something like number 2. We want to find the sine of 225 degrees. Well, let's draw a little ASTC chart. Let's figure out what should we be here. The sine, is it positive or negative in the third quadrant? Because that's where we are. And we know, since tangent is the only one that's positive in quadrant 3, that sine of 225, I'll write it over here, right? This should be equivalent to negative, because we're in the third quadrant, sine of, well, we need to know our reference angle, right? And our reference angle is always what we make with the positive x-axis here. Okay, so how do we figure it out if we're in quadrant 3 in this case? Well, again, I always find it's easiest to sort of reason this out based on your quadrant angles and how far you've gone. We know that up to this point is 180 degrees, but our angle is 225. So how much further do we have to go? Well, let's take out the 180 we already traversed in this case, right? So 225 minus 180 gives us 45 degrees left over. That's how much would be left over in this angle. So sine of 225 is equivalent to negative sine of 45 degrees, right? And now we need to know what the sine of 45 is. We're going to use our 45, 45, 90 right triangle, right? Which are in this ratio. So here's, let's say, our opposite. This is our hypotenuse, because that's what we need for sine, SOHCAHTOA, right? So this is going to be equivalent to negative, looking at this, opposite is 1 over hypotenuse is radical 2, which, if you remember from our last lesson, once we rationalize this, this is just equivalent to negative radical 2 over 2 from rationalizing the denominator. So we get the positive negative part from the ASTC. We get the numerical value from the reference angle, which we always figure out from adding and subtracting angles based on where you are in the quadrant. Now, you might be thinking, is there just a quick formula to get this? And yes, it works out that way, but just like last lesson, it's not really helpful to memorize this. You're much more likely to forget just a formula. A picture is your best friend. It's really easy to sort of work this out and know those quadrant angles to help you, right? But in case we can't, what we've seen is that in quadrant 4, our reference angle, right, is going to be equal to 360 minus whatever our angle is. In quadrant 3, we just figured out that our reference angle is equal to whatever theta is minus 180, right? So we have to keep going, and then we take out the 180 we already did there. Sort of just reasoning backwards. And in quadrant 2, what we could also find is that our reference angle is going to be equal to 180 minus theta. That's going to figure out basically how much extra we have to go. Again, I don't find memorizing these formulas is really helpful. Even right now, I kind of had to look at the picture and derive what they are. I don't just memorize what the reference angle is in each quadrant. It's much easier to work these out. So let's look at number 4 here, where we are in quadrant 2. So our process, just to summarize again, we need ASTC, right? And now we're looking at the cosine here. So we need to figure out in quadrant 2, is the cosine positive or negative? Well, quadrant 2 has an S in it, all students. S stands for only the sine is positive, which means the cosine in this case is going to be negative, right? Or in other words, cosine of, it says theta is 150 degrees, is equivalent to negative cosine of, well, we need to know that reference angle now. That's the other part, right? And again, the reference angle is this little one here. And the way I reason this out is, well, I know going from the positive x-axis to here, if that was my arc, well, that's a full 180 degrees, but I'm only going 150. So the question is, how much extra do I have to go to get to 180? And when I think of it like that, it's a lot quicker for me to realize that, well, it's just another 30 degrees to go. But the way I would get that, of course, is exactly what I was just saying. It's really just 180 minus 150. And that's going to give me 30 degrees, right? If I just plugged into that quote unquote formula I just wrote on the last page, but it's much easier to just reason that out, right? So coming back to the problem now, what we figured out with our ASTC chart and the reference angle is that the cosine of 150 is equivalent to negative cosine of 30 degrees. And now we just need to remember what cosine of 30 degrees is, right? We could use our special right triangle one more time, our 30, 60, 90. So here's my 30. They're in 1, 2, radical 3. So cosine is always equal to adjacent over hypotenuse, or in this case, that's going to be negative cosine of 30 is radical 3 is the adjacent over the hypotenuse is 2. Okay, so let's do a couple more as we get the hang of these. I'm going to skip down just so we can get some extra room here. Let's do number 7, where we're talking about the cosine of 135 degrees here. Well, we need to know the cosine of 135 degrees. So we have our A, S, T, C. And we see then that since we're in the second quadrant, this has to be negative one more time, right? So cosine of 135 is equivalent to negative cosine of, well, now I need the reference angle, which is this one here. And it's the same reasoning as before. Well, if I were to go all the way over to that negative x-axis, that's 180 degrees, but I only went 135 degrees, right? So how much left do I have here? Well, I would have to go another 45 degrees to get there, or again, just 180 minus 135 is going to give me 45 degrees, right? So cosine of 135 is equivalent to negative cosine of 45 degrees, which we know from yesterday, or we can work out with our special right triangles as we've been doing, is just equal to radical 2 over 2, okay? And that's how we're going to find the exact value for any of these problems wherever we see them. I'm going to do one more on the next page where we're not given the coordinate axes beforehand, but really, again, that just means we have to draw our coordinate axes and figure that out ourselves. So why don't we do one that's slightly more challenging. We'll do like number, let's do number 14 in this case, sine of negative 120 degrees. Well, we can do this a couple ways. One way is we can draw that angle, negative 120 degrees, by going backwards, like we practiced in the first or second lesson here. Or the other way we can do it, because of coterminal angles, we know that sine of negative 120, if I just add a full revolution to it, if I add 360 degrees, they're going to be equivalent there, right? So this one is the same as sine of, let's see, negative 120 plus 360, that's going to give me 240, right? So this is equivalent to sine of 240 degrees because they're coterminal angles. We did that just by adding 360. So now I got to see where is 240 degrees. Let's just draw our axes. 240 degrees. We see we go over 180, but less than 270. So we're somewhere over there in quadrant 3. Right? So that's our theta, and our reference angle is this one over here. So if we've gone 180 degrees, but we need to go 240 degrees, well, what's left over? We would have to go another 60 degrees there, right? So this is going to be numerically equivalent to sine of 60 degrees, which again, I just reasoned out here, but the way we can figure it out is if we're in quadrant 3, our reference angle is always just our angle 240 minus 180 degrees, right? For that 180 degrees we already went, which just gives me 60, right? And now we need to get the SIGN sign, right? So we have ASTC. We're in quadrant 3 here, which tells me that only the tangent's positive, or in other words, that the sign here is negative, right? Excuse me. So piecing this together, then we have that the sine of 240 is exactly equivalent to, well, let's go back even further. The sine of negative 120 degrees is the same as the sine of 240 degrees because they're coterminal angles. And then we have that the sine of 240 degrees is equivalent to negative sine of 60 degrees. And we figured that out from our ASTC chart as well as our exact values. And now we know that the sine of 60 degrees from last lesson is equal to negative radical 3 over 2. And I know, yes, last lesson I told you all that the picture you should have in mind are the special right triangles, and that's going to help you figure them out and not to just memorize these. I'm just going ahead and skipping forward to the answer because I've been doing this for a lot of years and they're kind of just stuck in my head. But as a recap, if we want to figure out what this is here, if that's our 60-degree angle and this is our 30-degree angle in our 30, 60, 90 right triangle, the sides have this relationship. So sine here is opposite over hypotenuse, right? So we just have radical 3 over 2 in that case, right? I just want to look at number 15 just to remind ourselves what function notation is, but I'm going to allow you to finish those on your own here. But it says, given the function f of x equals 4 cosine x minus 2 sine x, determine the exact value of, and then it gives a couple problems here. It says f of 60 degrees. Well, function notation here means just plug in 60 degrees wherever we see x, right? This is the function of x is this 4 cosine x minus 2 sine x. X in this case is 60 degrees, so f of 60 degrees is just equal to 4 cosine of 60 minus 2 sine of 60. Right, in this case, we can just go ahead and plug them in. We don't need to mess with reference angles here. We know cosine of 60 is radical 3 over 2 minus 2, I'm sorry, not radical 3 over 2. Cosine of 60 is 1/2 minus 2 sine of, I'm sorry, we don't need to write sine. We know sine of 60 is radical 3 over 2. And then we would just figure these out. We have 2 minus radical 3, and that's our final answer here. That'll be the same idea for parts B and C, except we might have to find our reference angle or our coterminal angles there. So that's it for lesson 4 here. We're talking about exact values in other quadrants. Remember, the key part is just break it down. Break it down into steps you already know here. Use the ASTC chart to get the SIGN, positive or negative, right? And use the reference angle, which is the angle made with the x-axis, to get the exact values correct. That's all for today.